Hello, everyone. Welcome to the sixth chapter of A Levels Physics, which is deformation. So, the first module is all about stress and strain. And the first thing you need to know about is the type of deformation we will be dealing with, right? So, the deformation we will be dealing with is done by tensile forces, right? Compressive forces, forces that compress the object, or tensile forces, which uh, extend the length of the object, right? So these are the two deformations, and you'll only be dealing with one-dimensional deformation. And what that means is you will only be measuring the change of length, right? The change of length, right? I'm just going to write measure only change in length. So you won't be dealing with the thickness changing of the object you are compressing or extending, just the change of length. So that's a good thing. That makes it very easy. So now on to Hooke's law, which suggests that Hooke's law states that the force applied to cause an extension is proportional to extension, right? Now, what that means is the force applied is proportional to x, and this results in F, the formula F is equal to kx, where F is the force, x is the extension, and the k is the spring constant depending on the spring, right? So you have to remember that this is very specific to each object, not even a material. It's just specific to an object that you have. For example, this is a wire of copper, right? For example, this is a wire of copper, and this is another wire of copper, which is a little bit thinner, and these two will have different k values, right? So this k is very specific to each object. So just keep that in mind. Now, terminology. I'm just going to draw a diagram for this. This is the spring, for example, that we are going to extend, right? Now, the weight that we attach to it is called a load, right? And the length increase or change in length increase or decrease in length is called extension. So even if the length is decreasing, you will call it extension in this context. Now, the last thing you need to know about the last term is limit of proportionality. Now, I'm not going into the graph right now, and we'll go into the graph in the next module. But what you need to know is the point till which an object obeys Hooke's law. Now, Hooke's law, although very easy to understand, is not absolute, right? You probably have seen that extending a spring too much just breaks the spring down, and the spring can easily get extended after a certain point. So at the point till which an object obeys this law, where F is equal to kx, that point is called limit of proportionality. And just a small portion of the graph, you probably have seen this in your O levels, and this is limit of proportionality, where everything is constant, gradient is constant, gradient would be k here, right? F over x, and this just goes haywire after this point, and till this point, this is called the limit of proportionality. So just remember that. Now moving on, stress. Stress is the force applied per unit area, right? So this is just pressure. It's also measured in pascals. So for example, this is a wire. Let's just go back to our previous example of copper wires, and this is a thinner wire. Now, if you apply a force of 10 newtons here and a force of 10 newtons here, the pressure it will experience, this one will experience a greater pressure basically, right? So stress tells us how much an object is being pulled actually, because a thinner wire would get pulled more with a smaller force, and a larger object would get a less of a tension force with the same amount of force, right? Less tension with the same amount of force. So that is something you need to remember, and we'll see how it nicely comes down to Young modulus when we get to it. Now epsilon, strain denoted by epsilon, is the extension divided by length, right? So it's a ratio of how much the object is extended with the force. Now both of these things, right? Both of these things comes down to the Young modulus, or E, denoted by E, of a material, which is stress over strain, or F over A divided by X over L, and this becomes F times L divided by AX. So this is the final formula of Young modulus. And the Young modulus, now we discussed that K is not material specific but object specific. But Young modulus makes the thing material specific. Now, material specific. Now, the Young modulus for each spring would be the same. Each material would be the same, right? But the K was only applied for an object, a specific object with specific thickness and specific extensions, right? But this gives us a whole formula. So this is a nicer formula, right? Now the graph of Young modulus is such that strain is here. Stress is here and strain is here. And this is the graph of Young modulus. And the gradient gives you E, right, is equal to M. And this is the formula basically. Now moving on, and the final thing is the extension. Now, the experiment to calculate extension. Now this is the apparatus that we're going to be using, and I'm just going to go over it one by one. Now this is a piece of wood that we've attached a wire to, and we've clamped this, right? We have clamped this so it can't move, right? So the wire is attached to it, and then the wire is attached to a pulley and a load, right? This is a load here, attached to a load. Now to measure the extension, we have put a scale here and attached a tape like this to the wire, right? So if this tape moves, however much this tape moves, we know that this wire has extended that much, right? Now another thing that we do is measure the thickness, right? Thickness is known. Thickness or radius or whatever, right? Radius is measured, and we take the cross-sectional area using the formula of circle area, right? So here are the steps. Measure the diameter of wire, and using a micrometer, and then calculate area using pi r square, right? Now the second step would be to attach the wire to the apparatus shown. Attach apparatus and a known weight, right? And a known weight. So the weight must be known, right? Because we need F, right? This force mg, we need to know this mg because we need F to calculate Young modulus, right? F over A, remember? And the last part is note the length of spring before and after. Calculate x, which is the extension, using length after minus length before is equal to x, right? Finally, use the formula E is equal to F times L, A times X, which will give you the Young modulus. So this is basically a simple experiment. If you if you go over this one time, you will understand it's a simple experiment and nothing fancy here. And this was the last thing that we need to complete this first module. I'll see you guys in the next video. Thanks for watching. Goodbye.